In this episode, we're going to be looking at Venn diagrams. Our objective: draw Venn diagrams to show the intersection or union of two sets. You are given the responsibility of planning a birthday club for your class. You will be expected to collect a weekly contribution from each student to buy gifts for the boys and or girls each month. You thought of a brilliant idea. You decided that the first step is to collect the information on the number of students that celebrate birthdays in each month of the year. The table below shows the data you collected. So here we have birthday club. There's the table, boys. We have girls. So we split this into months of the year and number of students. So January for the boys 2, February 4, March 5, April 1. No boys born in May. 1 is born in June. None for July. August we have 2 boys. September 4. October, November. No boys are born or celebrate a birthday. And for December, only 1. For the girls, we have 4. For the girls, we have February, March, and April. No girl is celebrating a birthday. May, we have 1. June, we have 1. July, 3. August, 4. No girl celebrates a birthday for September. October, 3. November, 4. And December, again, no girl celebrates a birthday. It says, use the table above to answer the following questions. In which month will you have to buy the most gifts? How would we work that out? Would we need to add this way? So for January, 6 gifts. For February, 4. For March, 5. April, 1. May, 1. June, 2. July, 3. August, 6. September, 4. October, 3. November, 4. Alright, so it looks like 6 would be the highest one. 2 boys, 4 girls. Okay. Outside of that, the closest we got was March, which would have been 5 boys only. Alright. Let's see. In which months will you have no birthdays? In which months? Okay, so I see for the month of October. Well, if you're looking at it just for the boys, then for May, the month of May, July, October, and November. For the girls, would have February, March, April, and September, as well as December. But is there one where we find both of them not having a birthday? January, February, March, April, May, June, July. Nope. So you'd have to look at it boy versus girl. Okay. In which months would you need to buy gifts for boys? For both boys and girls. Let's see that. So for January, yes. February, no, because no girls are celebrating birthdays there. So January, yes. March, no. April, no. May, no. June, yes. July, no, because for July we have no boys celebrating birthdays. For August, yes. September, no. October, no. November, no. December, no. So for the months of January and I think it was June and August, those 3 months we see there. All right. If one gift costs $100, how much money would you need to raise for the birthday club in total? I guess we'd have to add all of these together and then multiply that by 100. So we have 6. Let's see if we could get a rough check on that. So we have 6 and Then we have 4. 6 and 4 would make 10. Six and 4, 10, plus for March we have 5. For April 1. For May we have 1. For June we have 2. For July we have 3. Let's see. For August we have 6. September we have 4. October we have 3. And let's see, November we have 4 and 1. Alright, so rough check I have 40. So if it's 40 and we multiply that by 100, you would get $4,000. Okay, so we can double check that to make sure. Alright, so what we'd need to do, we'd need to add the total for each month, then add all of those, and then see what we come up with. Is it 40? Then if it's 40 gifts, multiplying that by 100 would give us 4,000. All right, let's see. It says here, you are at a toy store to get gift ideas for the birthday club. The store manager gives you a list of all the items that you can get for under $100. You see the list below: transformer truck, toy watch, tiara, headphone, football, doll. You were able to purchase all the items on the list and were asked to group them based on boys, girls, or both. List each item in the correct group. Boys. We're going to get into a little trouble here, because some girls might like the transformer truck. All right, but we'd typically put that with boys only. Okay. What about toy smartwatch? I think both groups would like that. Tiara, girls only. Football, they would say boys only. But we know girls that play football in our class right now and score a goal. So that could be for both, right? Headphones, both. But the doll, we'll put it with the girl side. Okay? So what are we doing here? We're taking these items and placing them into groups, right? So that we can make those distinctions. All right. All right. We're not getting into whether we think they're fair or not, or they're politically correct or not. We're just using the traditional rules and placing them there. Okay. Now, what does this mean in terms of a Venn diagram? A Venn diagram is a diagram which shows all the elements or members of all related sets. The universal set is represented by the symbol that looks like a U, or E, and is shown as a rectangle on the Venn diagram. The universal set is made up of two individual sets, which are shown as circles, as in this case. The figures below show a Venn diagram with the universal set and the sets it contains. So here we have A and B, okay? Intersection of two sets. The so this follows up from our last look at sets. The shaded part of the Venn diagram below shows an intersecting of two sets being compared. So A and B, what do A and B have in common? It would be the area that is shaded here. The intersection of two sets contain all the members that are common between the sets and is represented by the symbol that looks like this. Okay. The intersection, I don't think this is the right symbol, you know. This symbol here is the one that represents the union. All right. I think it's supposed to be one that looks like the N. Okay. The intersection between the two sets below AUB. I don't think this one is right. If we go back to what we were doing in the previous lesson, we would see that intersection is not written like this. Okay, so this might be a typo. Okay, let's go to union. It says the union of two sets. That would be all of the section here. You see all of them shaded here. All of the members of both sets listed without repeating. All right, so let's go. The union of two sets, the shaded part of the Venn diagram, is called the union of two sets being compared. The union of two sets shows all the members of the set and is represented by the symbol that looks like the U. So we can't have the intersection here, so be using the same symbol as the union. So clearly this one is a mistake. All right. The union of the two sets is therefore written as a with the U symbol here, B. All right, so the union of A and B. So just to go back to the previous lesson on sets, okay, so that would have been sets part 2, okay, or sets continued. Look at this. We're talking about the intersection here, and let's see here where it says we use the symbol that looks like this to represent the intersection. So we have a mistake here where they have it incorrectly stated. Okay, so let's go to the last section. It says, now let's look at the example below. The universal set contains all the numbers less than 20. So all of the numbers less than 20. Therefore, the universal set has the counting numbers less than 20. So here we list them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. If there's a less than 20, 20 cannot be included. All right. Set T would be odd numbers less than 20. Odd numbers less than 20. Set T contains prime numbers less than 20. Okay. I wonder if that is set T or set X. So here again another error. So set X would be prime numbers less than 20. Okay, so let's go. So set T has 1, 3, 5, 7, 11, 13, 15, 17, and 19. These are all odd numbers less than 20. Now set X has prime numbers less than 20. Let's go with this. So what are prime numbers again? Numbers that have only two factors, 1 and itself. So 2, the only factors of 2 would be 1 and 2. The only factors of 3, 1 and 3. 5, 1 and 5. 7, 1 and 7. 11, 1 and 11. 13, 1 and 13. 15. 15 prime? No, sir. 15 can't be in the prime, because 15 is a composite number. So 15 can't be over here. Are we seeing this? So 15 can't be in this list. 15, because 1 can go into 15, 3 can go into 15, 5 can go into 15, and 15 can go into 15. So this is a composite number. This one is out. Error. 17, 1 and 17, 19, 1 and 19. So let's bear this error in mind, please. Okay, let's go with this. Now, let's see how these sets are represented on a Venn diagram. So we have set T and set X. Okay, so here we have set T, odd numbers less than 20. Okay, so we have 1, 9, and 15. Cool. So the 15 is represented here. Cool. Then 2 would be even numbers less than 20. All right. No. 2 would be set X, not 2. Set X would be what's this one? Prime numbers less than 20. And what do they have in common? We have 3 in common, 5 in common, 7, 11. What else? 7, 11, 15. No, it can't be 15, I remember. 13. Yes, it's 13 and 17. Now, what are the other members that are outside of this? It would be 4, 6, 8, 10, 12, 14. 15 should be here as well. 16 and 18. No. 15 would be in the odd number set, so that is, it's in the right place. Okay? But 15 should not be here. 15 should be in set T only and not in the intersection or in set X. So this part is correct where 15 is concerned, but 15 should not be represented in this list. All right. So this explains what is happening here. Again, the universe. So in this box, in this rectangle, we're going to find all the numbers from 1 to 19. Okay, from 1 to 19. So here we have 1. We're going to find 2, then 3, then 4, then 5, then 6, then 7, right? Then 8, then 9. We have 10 down here as well. 11 in the middle. 12. Then we have 13, then 14. Yes, 15 here. 16, 17, right? 18. And we should have 19. 19 is not even represented here. So I think 19 should be in T as well. This can't be 9. We need 19. Okay? We need 19. Maybe an error. 19. Alright, because it would be set T being odd numbers less than 20. 9, I think we need 19 as well. Because why would 9 be left out? Look, see 9 here. But in set T with odd numbers less than this, I see 1, 3, 5, 7. We should have 9, 11, 13, 15, 17, and 19. Okay, so I think 19 should be here as well to represent the odd numbers. Okay, so we'd have our 9. When we're counting, we'll get our 9. Because remember, and this is why it's important to check, because if I was not counting a while ago, to look for each member to say 1, and we find the 2, then we find the 3, we find 4, right? We find 5, we find our 6, we find the 7, we find 8, we find 9, we find our 10, yes, we find 11, we find our 12, we find our 13, we find 14, we find 15, 16, 17, 18. Where's our 19? Because 19 needs to be represented here. And it says 19 should be in the middle then. Yes, because 19 is common to both. So they have left out 1 there. Alright, so it's common to both. 19 would not be here because 19 appears in both. Okay, so 19 needs to be here. Alright. Finally, let's close it out now. It says, look back at the birthday club data we collected. Draw a Venn diagram placing all the toys in their correct set. Based on the Venn diagram you have drawn, complete the following. Set of girls only, the set of boys only, the set of boys and girls, that's a union. Can't be the union here because we have the universal set. Alright, maybe, let's see. The set of boys, the union of the boys and the girls, and then the set as in the universal set. I am thinking that probably they want the intersection, what would be common to boys and girls, right? I think that would make better sense here. What would be common to the boys and girls? So what overlaps? So what toys or what things would overlap? So work with that one for me here, okay? The challenge here. So set of months with the same amount of boys and girls sharing the same number of birthdays or the same birthdays. So that's the challenge. You can work out the set of the months with the same amount of boys and girls sharing the same birthdays. So in this episode, we looked at Venn diagrams, and I'm hoping now that you are better able to draw the Venn diagrams and show the intersection and union of at least two sets. Take care. I'll see you in the next episode.